Okay, question number 1. Two identical 300-degree arcs are joined together to enclose the area shown in this picture. Both arcs are part of identical circles and with a radius 12. Okay, radius 12, which means this is 12. This is 12, right? Radius 12. Now the arc that create arc for 300 degrees is gonna be this. Okay, this is one arc. Okay. And here we have the other arc. These are two identical arcs, 360 degrees. The whole circle is, 300 degrees. The whole circle is 360. That means this overlapping part is creating the area of, it's just like a bited pie, yeah? That somebody has piece of pie. So this is 300 degrees. That's what we are talking about. All right? So let me shade in the darker area this this piece. This is a part that overlapping, right? Each other. Okay? All right. So I'm going to read the problem again. So make sure we understand what we are doing. So each one of them is 300 degrees. This is 300 degrees. This is 300 degrees. All right, with radius 12. So we need to find the entire area of these both circles. Okay, calculate the area of this entire shape that shows here. These two circles that are overlapping each other. Okay, so if we have practically, it's gonna be equal this shaded area that we have. Okay, let me shade this area. This shaded area, I need to find the area of this shaded area, right? And this one also. This shaded area. Okay, and plus it's gonna be the area that is created by this rhombus. So let me take this color. This is not the best color, so we can see well. This green one maybe, huh? Yeah, we can see well. Yes? Okay. So this is what we need to find. So the area of red color plus area of the blue color and plus the area between them that is limited by rhombus. All right? Okay. So, well, let's start working. We know that the area of entire circle, right? The area of entire circle is pi r squared. Yes? (360°). Let me put this way. 360 degrees is pi r squared. All right? But we have 300 degrees instead of 360. So I'm writing down 300 degrees. And it is equal S area. So we need to find 300. So when we created proportion, so our proportion is going to be equal. So I'm doing cross multiplication. It's 360 times S and 300 times pi r squared. We are going to have 360 degrees times S is equal 300 pi r squared. Let me take off this degree in the equation. Okay, so from here, I'm going to divide by 360 because to find S, right? And I will find the area for 300 degrees. So from here, 360 is gone. This 0 is gone with this 0. And 30 and 36, I can reduce by 6, right? Here is 5 by 6, here is 6. And area S is equal 5 over 6 pi r squared. Yes? All right. Next. So, since we have, this is area for only one, 300 degrees. We have two of them, right? This is S1. This is also S1 because they are identical. Circles are equal by perimeter and area, so by circumference and area. So therefore, two S's are going to be equal 5 over 6 times 2 times pi r squared. So this is 1, this is 3, right? Canceling. And we are getting, let me write down here, total area, total S. So from here, total S is equal 5 over 3 times pi r squared. So from here, S is equal 5 over 3. R is going to be how much? 12. Squared is going to be, okay, 12 squared times pi, right? And it's going to be S is equal 5 times 144 over 3 times pi. Now, 144, is it divisible by 3? Looks like this is 1. 14 by 3 is 4. 12, 24, 48. Okay, and 48 times 5, it's 40, 20, 240. It's going to be S is equal 240 pi. So this is for two S's for both, which means here I'm marking down this and this together. S is equal 240 pi. Okay. Now, next, let me make it more. Very good. All right. Next, we are going to find the area of this rhombus and add to each other, because add to this area that we got. Okay, add to this area that we got. Because we haven't added, we didn't calculate this area of rhombus. Okay, how we are going to figure out the area of the rhombus. So let me write out this area, this rhombus. Okay, writing out. So first of all, let's identify for the students who have no idea what means rhombus. So let's give the definition of rhombus. Rhombus is a parallelogram with the equal sides. Okay, sides are equal. And two opposite sides are parallel to each other at the same time. Now, which property is specific to rhombus? The diagonals are bisect each other in perpendicular. Okay, here in perpendicular, right? I don't want to draw there because I'm not going to use it. Okay, well, let me do it in perpendicular. This is one. This is another. Yes, which means they create at a right angle, correct? All right. And these diagonals divide the angles by half, which means this angle will be equal to this one. This angle is going to be equal to this one. They divide by half, all angles here. All right? Now, we are done. Understanding of rhombus. Now let's figure out what is the formula for area. What is the formula for the area of rhombus? Because we need to find the area of rhombus so we can add to this the shaded area we found, right? To get the total area for 300-degree sector and rhombus together. There are three ways to calculate the area, and let's figure out which one is going to be our choice. First one is area S is equal 1/2 first diagonal times by second diagonal. Let's say this is first diagonal, this is second diagonal, vertical and horizontal diagonals. Okay, so this is one way. Second way is we are going to provide perpendicular. What color to use? So we can, okay, I'll use black one. Provide perpendicular to the opposite side. Okay, let me see. Or maybe it would be better if I draw separate. Okay, I'm going to draw separate. This is for first one. Now I will draw for the second one. Okay, and here is my height. Okay, this is my height. And this side is side A, and this is, okay, alpha angle. So, second way to find out the area is going to be the height, obviously it's create the right angle, height times base. That's the second formula for the area of rhombus. And the third formula for the area of rhombus is square of side, meaning a squared, times sine alpha. Okay? So, since we don't know the diagonal, so this is not going to be our case, but we can use either this one or this one. Most likely, we'll see. We can use either one, number 2 or number 3. Okay, formula 2 or 3. Okay, let's see what we can do here. I'm drawing one more time this rhombus, and we can start working on it to figure out the area. There are a couple of interesting theories I'm going to apply. I don't know if you know it, so, but you will hear definitely now from me. Okay, as you can see, if I provide, let me see, let me do better one second. So, there is a theorem that the height that is provided from the obtuse angle, to the opposite side, is splitting that side, meaning this side. What is happening? This side is equal this side. So if we have A, B, C, D, and this is my K, then I can insist, since this is a 90 degrees, this is a height, right angle, then I can insist that AK is equal KD. At the same time, we know since we have rhombus, our sides are equal, right? So, and AD also equal. Here is a thing, very interesting theorem. In the right triangle, in the triangle with the right angle, okay, if the one leg, this AK leg in our case, since AK is equal KD, and that is half of AB, correct? Hypotenuse. Why? Because AD, look at the rhombus, AD is equal AB. So if BK, the height, is breaking into half, dividing into half, and there is a such theorem that the height that provided from obtuse angle to the opposite side, dividing that side by 2 equal parts. So therefore, AK is 1/2 of hypotenuse AB. And that's mean the angle that is opposite to half of hypotenuse leg is 30 degrees. So that's mean if AK is half of hypotenuse AB, then the opposite to AK angle is 30 degrees. Has to be 30 degrees because that is the theorem, that is the rule. So if the leg is equal half of hypotenuse, then the angle opposite to that leg is 30 degrees. So if this angle B is 30 degrees, then angle A is 60 degrees, right? Because 90, 30, and 60, sum of triangle angles in the triangle is 180 degrees. So let me see, if K is 90 degrees, then angle A will be equal 180 minus angle K minus angle B, right? And we will get angle A, that is going to be 60 degrees. Okay. So since I have the angle 60 degrees, I can use the third one, right? Which is going to be A squared, and A is 12, right? Everywhere. So based on third formula, either I can take 12 squared, or A squared times sine 60 degrees, so which is going to be 12 squared times sine 60, or using second formula, I can use H times A, or 12, right? And H, I can find out, H is going to be equal AB we see H, let me write down here, H is equal AB times sine 60 degrees, which is going to be, H is equal, it's 12 times sine 60 degrees is square root 3 over 2. So it's going to be equal 12 times 12 square root 3 over 2 times 12. Okay, and here is also 12 squared, 144, times sine 60 square root 3 over 2. All right, it's a little bit, I guess, overwhelming information, but we need all that to be able to calculate. What two theorem we used? One very important one, that the height that provided from the obtuse angle to the opposite side is breaking that side, dividing into two parts, two equal parts. Here. This is my angle at the height, and it's breaking down this side equal AD into AK equal KD. This is one property of rhombus, not property, theorem of rhombus that I used. The second one is, so because it's breaking into two parts, equal parts, AD, that's mean 12 divided by 2, it's going to be 6. Each piece is going to be 6. And since it's a leg, 6 is a leg, and the leg that is half of hypotenuse, half of 12, that is IB, AB, hypotenuse, right? Then the opposite angle to that 6 must be 30 degrees. Okay, it is proven. So this is what we used here. So if in both cases I am getting 144 square root 3 over 2, which is going to be 72 square root 3, right? This is 1, this is 72. Same way, 72 square root 3. Okay, so this is the area of rhombus. So from here, total area is going to be equal area of the sector, which is 240 pi, plus 72 square root 3, and that is going to be our final answer. So this expression is the area for this both circles that overlapping each other. Okay? That is gonna be our problem. Okay, question number 2. What do we have? Question number 2. So we are given 7 to power 3x plus 2. In terms of n, how to express this expression in the terms of n, given that 7 to power x is equal n. Let me rewrite it nicely. Okay, so 7, 3x plus 2 is equal, I'm going to break it down, 7 to power 3x. I'm trying to release 7 to power x so I can replace with n. That's my goal. 7 to power 3x times 7 to power 2, right? Because we know a to power n times n plus m is equal a to power n times a to power m, properties of exponent. All right. So from here, 7 to power 3x, can I write down 7 to power x to power 3? And that's the formula. A to power mn is equal a to power m raised to power n. Let me use the same red color so it won't be Christmas tree. Okay. And this is times 7 squared, 49. Right? Now I'm going to replace x 7 to power x. I'm going to replace with n because it's given that 7 to power x is n. So it's going to be n to power 3 times 49, which is 49n cubed. Yes? And question number 3, it says, which values, we are given an expression, first of all, 2x squared minus 3x plus 9 over x squared plus x minus 6. Calculate the value of this expression for which this expression is undefined. When our expression is undefined, whenever we have division by 0. So to be able to have it undefined, we have to put x squared plus x minus 6 equal to 0. Right? That's the case when it will be undefined. So let me factor it down. X plus 3, x minus 2 is equal 0. And from here, x is equal negative 3, x is equal positive 2. So the answer is at the value of x is equal negative 3 or x is equal 2, our expression is undefined. Okay, problem number 4. What do we have here? The president of the college decided to retire in December 2009. He served in that capacity for 11 consecutive complete terms. Given that one complete term lasts 4 years, from the beginning of January on the first year through the end of December of the fourth year, calculate the year. Oops, I have it twice. Calculate the year in which the president began to serve his first term. Okay, 11 terms and at 4 at each term, right? Let me write this way. 11 terms and 4 years per each. Per each term. So that makes 11 times 4, total 44 years, right? So he wanna retire 2009. So I need to subtract, right? 2009 minus 11 times 4. And let's not to forget, it's retiring in December 2009. So I have to do plus 1 because we haven't counted that 1 year of 2009. Yes? So it's going to be 2010 minus 44, right? So 2010 minus 44, it's going to be 6, 10 minus 6, 1966. He started his work, he started his work in 1966. Okay? And one more. We have 4 to power x plus 1 equals 64. We need to solve it. Okay, so we are going to work this problem based on if a to power x is equal a to power y, since base is the same, a, then x has to be equal y. So let 64 bring to base 4. So it's going to be 4 to power x plus 1 is equal 4 to power 3. 64 is 4 to power 3. Therefore, x plus 1 is equal 3 and x is equal 2. That's pretty much all. Thank you for watching and I'll see you next time.